wanted to see the right answers here. So, A would have been in quadrant 1, B would have been down there, C would have been in quadrant 3, and D would have been in quadrant 2. Reference angle, 10, 15, 72, and 35. Now, this one got a little tricky. Some people were asking about it. Determine the measure of all the angles that have that reference angle. Well, 45, what's 45's reference angle? 45. The next one is going to be 135, because it's 180 minus, right? And then the next one is going to be 225, because it's 180 plus, and then 315, because it's 360 minus. 60 is 60, 120, 240, 300. 30 is 150, 210, 330. And 75 is 105, 255, and 285. Yeah? And then the last part, you weren't supposed to do number 8. Oh, you didn't have a number 8 to do. Sweet. Oh, I erased it. That's right. So if I do that, it should show up. Yeah, there it is. 72 in quadrant 4. That means it's down here, right? Where's the 72? That's in there. But we have to measure it this way. So what is it? 288. What's 56 in quadrant 2? 124. 18 in quadrant 3? 198. And 35 in quadrant 4? 325. Is everybody good with reading standard position and reference angles? Obviously, if you weren't here yesterday, this means nothing to you unless you watched the video. Is everybody cool who was here? All right. Let's move it along. This should be your page 194. Yeah? Okay. Point P is just xy, right? It's some coordinates of xy, yes? If point P is out here, then what do we know about x and y? They're both positive. X, y, right? And if I make the angle, there's my theta. Yeah? And that's my reference angle, right? Which one do I do trig with? The reference angle or the theta? The reference angle. In this case, they're the same. Yeah? Okay. What if P is out here? What do I know? Negative x and positive y. It would look like this. And where is my theta? Theta is over here. Where's the reference angle? There. And which of them do I do trig with? The reference angle. Right? What if P is down here? What do I know? Where's theta? All the way around. And where's reference? Right there. Right? And that little part of theta is what I do trig with. And Yes.
Chromebooks are like the worst things to come Why not just buy a normal laptop? I can actually run very cheap if you need it for sleeves.
Chromebooks are dirt cheap. All right, we're back. Sorry, ladies and gentlemen. What if P is down here? What do I know? Where's theta? All the way around. And where's reference? Right in there, right? Everybody cool? That's review from yesterday. Yeah? Okay, we need to do a little bit more review. What is sine always? Opposite over hypotenuse. In what type of triangle? In a right angle triangle. In a right triangle. I'm too lazy to write triangle. I'm doing that. What's cos? Always. In a right. Oh, man, I'm so lazy. I'm not even going to write right. Oh, yeah. And what's tan? Always. That's all review. That is what you should be bringing into the lesson I'm about to teach you. Does everybody understand all of that? Inside, outside, upside down, backwards, underwater, in your sleep. Yes? Close enough? Okay. Now you will notice I have the exact same drawing here, but it's big because we're going to put a lot of information on here. Everybody cool? All right, we're going to start in the easiest spot, the first quadrant. We are going to put a dot out there. Now, have I given you any values for that? No. But you know that they both have to be what? Positive. So this must be x, y. Agreed? Have I made a right angle triangle with which I can do trigonometry yet? No, of course not. I'm going to make it now. Everybody cool? Yeah. Where is theta and the reference angles? We do our trig with the reference angle. Right there, yes? I'm only going to put R for the reference angle. Everybody cool? Yes? Okay. Now, what then is sine of R? We just reviewed it up top. What is it? It's opposite over hypotenuse, yes? Well, where is opposite here? Right here is opposite, yes? Now, before grade 11, this was all you saw. Right? And there was no xy because we gave you a distance there, didn't we? But this is grade 11. How far is this distance? Yeah, you do. It's the y value, isn't it? Because we went up y, yes? So opposite's measurement is y. Everybody understand? Okay. What is the cosine of r? Adjacent over hypotenuse. Agreed? Okay. Where's that would be right here. Oops, I'm going to put it inside the triangle. Adjacent. And that, how far did we go this way? X. Everybody cool? Everybody good? Okay. Well, what then can I use to find the hypotenuse? How does tan find me a hypotenuse? Tan uses opposite and adjacent. What do you mean xy? How? Yes, you do. What mathematical theorem, x squared plus y squared equals c squared, which is the hypotenuse, which is right here. All right? So this, is it x squared plus y squared? Or is it something else? No. A squared b squared equals c squared. Do I want this number squared? What do I want? The square root. So the hypotenuse is the square root of x squared plus y squared. Is everybody with me? No. No, it's not x plus y. Right? Is everybody cool? So now, if I tell you this point is 3, 4, do you automatically know sine, cosine, tan? What is the sine of r? Well, we know it's opposite over adjacent, or opposite over hypotenuse, yes. But opposite is y, and hypotenuse is what? Square root. Square root of x squared plus y squared, right? What is cos? Adjacent, but adjacent is what now? X over square root of x squared plus y squared. And then what is tan? Which is? No. Y over x. Now, what are those values? What's our y value? 4 over, what's 3 squared? Plus 4 squared? 9 plus 16? 25. Square root of 25. So what goes here? 5. Oops, I should be using black because we're doing black reference angle here. 4 over 5. What's cos? What's adjacent? 3, because it's x over 5 equals, and what's tan? Which is y over x, which is 4 over 3. Is everybody cool? Everybody good? All right. We're going to come over here to this quadrant. We are going to put our x, y at the same spot, except, what's it going to be? Negative x and positive y. Does anything else change? I connect it. I make my right triangle. And there is my hypotenuse. So over here, without even thinking now, this is still y. What does this become? Negative x. So what is my sine of my reference angle? What? It's y over the hypotenuse. What's our y value here? First, it's y over the hypotenuse, right? What is our cos? X over hypotenuse. And what is our tan? Y over x. Now we know this is negative 3, 4 now. So what's our sine? 4 over 5. What's our cos? Negative 3 over 5. And what's our tan? What? Or 4 over negative 3. That's really what we should write. Does everybody see? Now, what does that tell you? R black R and red R are the same, aren't they? Right? And they have the same sign, don't they? So what does that tell you about that theta and that theta's signs? If this R has this sign, and this R is this blue theta, this R has the same sign, but this R is gray theta. What do you now know about gray theta and blue theta's sign values? They're the same. Good. Now, you're intelligent young people. Do the other two quadrants. Green R and blue R. Go. Alrighty. So now you should recognize what do you see is the value of all three in quadrant 1. They are the trig ratios are all positive. Right? What do you notice in quadrant 2? So what's the only positive one? Sine is positive. What's happening in quadrant 3? Tan is positive. What's happening in quadrant 4? Only cos is positive. And that sets up a new like SOHCAHTOA thing. Right? When I was a kid, we were taught C-A-S-T. Cast. Coses are positive down there. All are positive there. Sines are positive there. Tans are positive there. I've also seen teachers say acts. A-C-T-S. So they can go clockwise. All, cos, tan, sine. I don't care. Now, what did you notice is always a positive number? In all of this work we did up here, the hypotenuse was always positive, yes? Why is that? When you square the negative, you get a positive. So the hypotenuse is always positive. Now you will notice I called this section the unit circle, yes? That is because this makes a circle. And each of these hypotenuses is actually a radius. And a radius is always positive because it's a distance. Does everybody understand? Yes? Now, you will notice that I purposefully put our x's and y's out in the middle, yes? Because those give us regular angles, yeah? But there's also 4 very special angles, aren't there? What are the 4 angles that are very special on here? 90, 180, 270, and 360, or 0, because they're the same thing, yes? So that's what we're going to talk about now, because those 4 don't really fit this rule. Everybody cool? So turn the page over, and we'll talk about those 4. They only take a second or two. What? Oh. Well, you haven't listened for the previous 8 units, so I'm getting, I'm frustrated now. Yeah. In the next unit in finance, everything's in 18-point font as well. All right, but seriously, do we need to draw this anymore? No, because we remember from like 2 seconds ago, sine is now y over r, right? Or h, or whatever you want to call it. Radius of the circle. Cosine is x over r, and tan is y over x, yes? And we know that r equals the square root of x squared plus y squared, yeah? So what is r in this case? Square root of 16 plus 0, yes? Which is what? So r equals 4. Now we can do this easily. What is the sine of this angle? Sine equals 0 over 4, which equals 0, yes? What's the cos? 1, because it's 4 over 4, which equals 1. And what's the tan? 0 over 4, which is 0, yes? Now, if we were to draw it, 4, 0 would be right, 4, 0 would be right there, yes? Which is 0 degrees. Now, if you were to take your calculator and do the sine of 0, you'd get 0. It's neither positive nor negative. Everybody cool? And if you were to do the cos of 0, you would get 1. Okay? Everybody good? Okay, I only want to take a minute with these because, like I say, these are the special ones. So this guy, what's this guy's r? 3, right? So what's this guy's sine? 3 over 3. What's his cos? 0 over 3, which is 0. And what's its tan? 3 over 0. Wait a minute. What's wrong there? It's undefined. And if we were to draw it, 0, 3 would be right here, yes? So it would be 90 degrees. And if we were to do all those sine, coses, and tans, we would get those values. Everybody cool? Yeah? Okay. So let's do the next one. What's the sine? Or what's r first? 5. So what's sine? 0 over 5, which is 0. What's cos? Which is -1. And what's tan? 0 over -5, which would be 0. And that makes sense because where is -5, 0? It's out here. It's 180 degrees, right? And since it's out here, that's why my cos is negative. Everybody good? And lastly, of course, r equals 2. So sine is negative 2 over 2, which is negative 1. Cos is 0 over 2, which is 0. And tan is negative 2 over 0, which is undefined. And that's down here, 270 degrees. Is everybody cool with the 4 special ones? Like, there's not a lot of thinking there, right? It's 90, 180, 270, 360, or 0. That's why I rushed through it, because there's nothing much there, yeah? And it doesn't really apply that much. Like, how often in the real world is everything perfectly 90, 270? Not very often, yeah? So now that that's in our heads, let's actually apply this here. So number 2, we're going to do this 2 ways. We're going to draw it, and then we're going to use just what we already know, yes? So let's draw it first. Or what we just learned, I mean. Draw it first. Where is negative 411? Quadrant 2. It'll be out here, negative 4, and up 11, yes? Now, since it's in quadrant 2, what do I automatically know? What's going to be positive? Y, so sine. What's going to be negative? The x, so cos, and tan, automatically, because x is in both of those, yes? So, when we draw it, this is grade 10 trig, isn't it? Because the theta that we care about, is it theta or is it reference? It's the reference. So the theta that we care about is reference. And if we were going to do it from a drawing, the sine of the reference angle would be what? Can we do it in our heads right now, or do we need to do one more calculation? One more calculation, because what are we missing? Hypotenuse. We need that radius, right? So, oh crap, I've drawn it. Oh, I need that radius. So, radius equals the square root of what? 16 plus 121, yeah? Which is the square root of 137. Now, that's not a perfect square, is it? So what do we do with it? We simplify it if we can, right? 137 is a pretty barfy number. I'm pretty sure it's prime. So for our purposes, I'm not going to simplify it just because I want to get through the lesson, okay? So we're going to leave it like that. So there's our r. So what is the sine? 11 over what? Root 137. Now, what is then cos? Negative 4 over root 137. And what is tan? (11 over negative 4). That's when we draw it. But did we really need to draw it? No, because we know that sine also is y over r, cos is x over r, and tan, I always do sc, and then I start writing tan. Tan is y over x. Do I have every and r equals the root of x squared plus y squared? So did I even need to draw it anymore? No. But do I still need to know about this? Yes, because the angle that we seek is not really r, is it? What's the angle that we actually seek? It's on this side, yes? Because if I were doing trig right here, I would get the same r, wouldn't I? Everybody cool? Okay, try it on number 3. Except number 3, I'm being mean. If I were doing number 3, I would sketch it, and then I would just do the x's and y's. Does everybody agree with the sketch? Now, do we need that sketch anymore? No, because we know sine equals y over r, cos equals x over r, and tan equals y over x. And we know r is what? X squared plus y squared. So all we do is figure it out. What's this? It's 16 plus 9, so it's a square root of 25, so it's 5, right? Okay, so what is our sine? Negative 3/5. What is our cos? 4/5. What is our tan? Negative 3/4. Now, how do I find the value of the angle? Do I have the ratio? What finds me the value of the angle? You got to think back to grade 10. I know the decimal because this is 0.6, this is 0.8, and this is 0.75, right? When you have the decimal or the fraction, how do you get the angle value? Does anyone remember? Yeah, it's shift sine, cos, and tan, yes? So you get out your calculator. Now, if you're using this calculator, you need to be careful because you need to hit mode and make sure you have degrees highlighted. If you don't have this fancy calculator, you need to make sure that somewhere on your calculator screen being this gray space, somewhere on that screen you see a little D or the word DEG, or you're going to screw up the trig. If you don't see a D or a DEG, then you look on your calculator for a button that has DRG. It's sometimes with an arrow. And you hit it until you see D or DEG. Is everybody cool? So what am I going to do to find this angle? I'm going to go shift sine of what? I could use the decimal or I can use brackets. Negative 3 divided by 5 and close the brackets. Everybody cool? Now watch what my calculator is going to give me. Negative 37 degrees. Everybody cool? So my calculator gave me negative 37 when I did sine. Watch what happens when I do cos. What am I punching in here? 4 divided by 5. Gave me positive 37. And obviously, what am I going to get when I do tan? Negative 3 divided by 4. I'm going to get negative 37 degrees, yes? Now, you're intelligent young people. We know that we count this way, don't we? So how can this angle way out here be 37? Is it? It's the reference angle is 37. So that's why we still need to know how to draw it, even if we're not going to use the actual drawing. Everybody understand? So now we know the reference angle is 37, yes? So what then is theta? Theta is 360 minus 37, which is 323 degrees. Is everybody cool? Yeah? Yes? Okay. Now, weird stuff happens here. Sketch and determine the value. All right. So we see that we have a tan. So what does that tan mean? What does tan consist of when we're on the coordinate grid?
It gives us our x and y.
It gives us x and y. Oops, sorry, idiot head. Y and x, yes? Except that negative's right in the middle. We don't know which one is the negative, or do we? Read the question. The terminal arm lies where? In quadrant 2, which means it's out here, yes? So which is positive out there, the y's or the x's? So that must mean this is 9 and this is negative 5, right? So now we've sketched it. Do we care about the r? Do we need it here? Do we need the r? It's a yes or no question. Do we need the r? No, because we've already got a tan value, don't we? Can't we do shift tan of negative 9 divided by 5? Well, try that on your calculator, and what does it give you? It gives you negative 61. That makes little sense, doesn't it? Except when you remember, wait a minute, it has to be the reference angle, doesn't it? And reference angles, when we go counterclockwise, are negative, aren't they? So, since we know the reference angle is here, and we know it was negative 61, wasn't it? I go counterclockwise, so this is 61. But that's not the actual angle, is it? Because I want the standard position angle. So what is that? This side. What is it? Theta equals 180 minus 61, which is 119. Is everybody cool? Yeah? Okay. Now this next thing is just 8 calculator pushes. Just do them. Use your calculator. Sine 43 equals. Or if you have a backwards calculator, which I hope no one has because that makes this year difficult, 43 sine. And then give me all those decimal places. Just go. I don't remember them off by heart. I got to do them myself. And when you've got those 8, fill in the next 2 questions there. Don't bother with the y part of it. Just fill in the two blanks. We'll talk about y in a second. So everybody should have the same decimal place, right? We're all using the same calculators, yeah? So let's talk about why D and H are exactly the same.
Same with
E and F, yes. D and H, you could also have used E and F. Thank you. I'll do E and F in a different color. We'll do E and F in red. So here is our... Where would 10 be?
10 would be like first quadrant.
Right there, yes? 10. Where would 190 be? Third quadrant. And what would this be? 10. Everything is positive in the first quadrant, yes? Tan 10. Only tan is positive in the third quadrant. 190. 10. Everybody see? Okay. For the red one, where would 223 be? In the third quadrant, yeah? And the reference would be 43 degrees, right? Where would F be? Fourth quadrant, 317. And the reference would be 43. What's negative here? Everything except cos. What's negative here? Everything except tan. So, they're the same. Everybody cool? Okay. Where are the negatives of each other?
A and E or F.
So there's A and E and F, right? And I'll do B and C in light green. Although you don't really need me to do them, do you? Because you should be able to figure it out now, yes? A was what value? I don't remember. I can't see it. 43. Where's that live? Oh, I shouldn't have done black. Let's do orange. A, E, F. Quadrant 1, 43, yeah? Okay, where's E? We've already done E. That's 223 down here, yeah? 43, 43. But everything's positive up here. And down here, only tan can be positive. The other one's down here, 43. Sign can't be positive there. So please notice, the reference angles give you the same number, but a different value. Everybody cool? And then for B and C, where's B? B was 170. 170 is right there, yes? With what? 10 again, right? 180 minus 10, yeah? And where is F? Or sorry, C. C was 350, which is right down here with 10. No, it wasn't C. Yeah. They're opposite, because what's positive down here? Cosine. So the reference angles. So when you're doing work with your calculator, does your calculator know which quadrant you want? No, it's only going to give you a value, isn't it? Right? So you still have to understand the drawing, even though we can do everything with X's and Y's. Everybody cool? All right, let's try putting this into practice. Turn the page over while I get up to a bigger size. Okay, read that question. Before you draw or think about it, you already know a bunch about this angle, don't you? What do you know about the angle? And its sine is So its sign is negative. So if the sign is negative, can it be out here? No. Can it be out here? No. It has to be down there and down there, yes? Because sine is negative. Now, what do we know about sine? Hayden already told us it's opposite over hypotenuse, but what is it also now that we have just learned? Yeah, but now that we're on the coordinate grid, what else is it? Y over R, right? So what do we know this distance is? Negative 2. And this distance is? And this distance is? And this distance is 5. Do we need that to solve the problem? Or can we get a value of theta with only the fraction? We can, can't we? We can use our calculator to do shift sine of negative 2 divided by 5, can't we? Can't we? Okay. What does that give us when we do that on our calculator? Second function sine, negative 2 divided by 5. And what do we get? Negative 24. Now, unfortunately for us, unless we drew it, we don't know what that means, do we? But now that we've got it drawn, we do know what that means. Because we know that we're going to be dealing with reference angles, right? And there's the first one. So if this is 24, what's that? $360 minus 24, which is 336, yes? And if this is 24, what does that automatically make this one? 24. If that's 24, what's that? 180 plus 24, which is 204. So we didn't have enough information to find one specific angle, did we? There's two answers to this question. It's ambiguous. We don't know what theta we are seeking. Everybody cool? Everybody good? All right. Because this point right here could be 5, negative 2, couldn't it? Or it could be this point over here, which was negative 5, negative 2. Now, if I told you tan theta was greater than 0, then which is it? Light blue theta or red theta? It would be the light blue theta. It would be 204 because tans are positive there. Everybody understand? Spectacular. So, let's have a look at number 7. Ooh, number 7's weird. Why? It's between 0 and 360. Why am I specifying between 0 and 360? It's the whole thing, right? But why am I stopping it at 360? Well, that's 45 degrees, say, yes? What then is that? 405. What then is this? 765. Everybody picking up what I'm putting down? Because the circles can go forever, can't they? We just add 360 each time. We're at the same angle, aren't we? So that's why I'm specifying we can stop at 360. Right? Now, cos tells us what? It's negative, right? So where can this be? It can be in which quadrants? Where's the only places cos can be negative? Bottom right, and that's bottom right, cos is positive. Top left. Right? Now, what else do we know about cos? It's the same as adjacent over hypotenuse, but now that we're on the coordinate grid, it's x over r. So where our x value has to be here, yes? So how far is this red line? The horizontal red line, sorry, I should have done it this way. How far is the red line? Negative root 3. How far is the blue line? 2. How far is the green line? Negative 2. Right? Is that right? No. Good. The hypotenuse is where the 2 is. We don't know why. Well, we do know why, because the hypotenuse has to be the positive. But we don't know the y value, do we? Now, again, do I need this drawing to get a value? No. What will give me the value? Shift cos of this, yes? So let's go to our calculator and let's get it. My calculator's not turning on, so one of you has to do it. Oh, there it is. Shift cos negative root 3 divided by 2. And what do I get? That seems weird, doesn't it? Why is my calculator giving me the actual value? It's always given me stuff between 0 and 90 up till now, hasn't it? So it's given me 150 now. Okay, so it's giving me 150. Is that the reference angle? It's the theta angle. If you've not been paying attention and you don't draw it, well, 150 reference angle. Yeah? So we know that this one, 150, and weirdly, we got it from our calculator. But it gave us 150. So what does that mean the reference angle is? 30. 30. So what does that mean this reference angle is? 30. So what does that mean green theta is? 210. Oops. 150 degrees and 210. Now, that seems strange, yes? Because watch this. Second cos. I'm not going to put a negative there. Root 3 divided by 2. What do you think it's going to give me? Do you think it's going to give 210? That's your guess? Any other guesses? You think error? AJ, what do you think? No guess? It's not going to give me a decimal. Well, it might. But when I did -3, it gave me a perfect angle. What do you think it's going to give me? I heard somebody whisper the right answer. Kui, what was it? 30. Crazy, hey? Nuts, huh? Now, if we did Pythagoras here, right, we would find this side was 1. Everybody cool? Right? Because 4, r squared equals x squared plus y squared, right? Which means r squared minus x squared equals y squared, right? R squared was 2. 4 minus x squared, root 3 squared is 3, would equal 1, right? Then I square root that. What's the square root of 1 is 1. Everybody cool? So now I know it's 1 over 2, right? Sine here is 1/2. Everybody agree? Go to your calculator. Second sine 1/2. You think it's going to give me 150? What's it going to give me? 30. Weird. Okay, screw you. I'm going to do tan. Tan would be negative root 3 over 1. Yes? Right? Everyone agree? So let's check. Shift tan negative root 3. I don't need to divide by 1, right? Because root 3 divided by 1 is root 3, yeah? Everyone agrees? What's it going to give me? Let's see. Damn. Negative 60. Oh, wait. Tan is y over x. Sorry, I screwed that up. Second tan 1 divided by negative root 3. What's it going to give me? Hayden says 210. Give me negative 30. See what I mean? You have to, it's only confusing if you don't understand the drawings, right? And you'll notice it's only cos that messes with you, right? Because none of the rest of us gave us 150. It was just that cos. So you got to be careful. No. I will after you're comfortable with doing it. Because every time I tell you guys why, you get mad at me. Because we don't know how to do it. So you're going to practice it a bunch, and then I'll tell you why. After you know what you're doing. All right. I think that that's the end of the lesson part of things. Yes. Same as yesterday. There's 3 pages there. You don't need to do all of them, as always. Right? But again, I forgot in this unit to put any answers in. But you should be okay. I don't need to do number 1, do I? We can all sketch those, yeah? Oh, crap. Number 2 you can't really do either. Because we haven't done those triangles. If you've been working on number 2, don't worry about it. It helps that the book I photocopied number 3 out of has half the work done right there. So 3 is sine is what? 4 over 5. Cos is 3 over 5. Tan is 4 over 3. B. Oh, crap. Sorry. It recorded, though. B. Sine is negative 5 over 13. Cos is negative 12 over 13. And tan is 12 over 5, because they're both negative, so you get a positive, yes? I wanted just the ratios. Okay. C is R is, of course, 225 plus 64, 17, because it's 289. So that is 17. So sine is negative 15 over 17. Cos is 8/17, and tan is negative 15/8. And this one is R is root 2, so we don't use decimals. So sine is negative 1 over root 2. Cos is 1 over root 2. And tan is negative 1. Everybody cool? Should I go a little further? You should be able to do 4 pretty easily. Cos is negative, sine is positive. What quadrant? What? Cos is positive in quadrant 1. Where's the only place that sine is positive and cos is negative? Quadrant 2. Cos is positive, tan is positive. 1. Sine is negative and cos is negative. Quadrant 3. Tan is negative, but cos is positive. Quadrant 4. Exact values of sine, cos, and tan. This is exactly what you did in number 3, right? I think. Number 3. Yes. So first you find the R, which is 13, and then you do sine, cos, tan with X, Y, and R. Once I found the R, you should be okay, yeah? The R here is 25 and 9 is root 34. The R here is 36 and 9, root 45. And the R here is, 496 plus 9 is root 596. I think 24 squared is 576. So it's root 676. Everybody cool? Then you do your work. Now listen. So this one, the sine would be negative 3 over root 34, right? Does root 34 simplify? No, because it's 2 times 17, right? The sine in C is 3 over root 45, right? But 45 simplifies, doesn't it? It's 3 root 5, yes? So that's 3 over 3 root 5. What happens to those 3's? They cancel. So 1 root 5 would be the right answer. Now, would I accept 3 over root 45? Of course I would. But what if I use some test bank and the multiple choice had every answer simplified? Then you still know how to simplify, right? And then root 676. God, I don't want you to have to simplify that. But it's 26, isn't it? Yeah. So you would have been fine. I'm just thinking right now, of course it is. Are we good here? Should be good there. Is sine positive or negative? At 155. Cos 320? Tan 120? Cos 220? Oh, look at you. That's in our notes, number 7. That should be pretty good. You guys should have a good start off there. The rest of this is pretty easy. If I were you, I would spend most of my time, if I was trying to decide how I could slack off and do as little work as possible, I would make sure I could do 12 to 17. Because if you can do 12 to 17, you're sitting in a pretty good spot, like a B level for this part of what we're doing, okay? If you can do 20 to 23, you'd be getting an A on this section of any test. All right? And of course, I'll go over more of it tomorrow.